All right, this is the video, Series versus Parallel Circuits Lab 2. You're using this sheet here and the circuit software, simulation software, in order to do it. So you need to create this circuit here with a battery, ammeter, light bulb, and a switch. And this is what I've produced here in the simulation software. You go to step 2, and you're supposed to measure the current of the circuit and note the bulb brightness and record your information right there. So let's close the switch and notice that the current flowing through the circuit is 0.9 amps, and this is the brightness of the bulb. Step 3 says add a second bulb to the circuit. So we're going to add a second bulb just before the switch there. So I'm going to right click and split the junction, create a gap there to put the light bulb in. So let's bring the light bulb in and then add our bulb like that, and you'll notice that the current has gone down to 0.45 amps, and the brightness of the bulbs is actually a little bit less than what it was before. So it says measure the current of the circuit and note the brightness of the bulb. So the current in the circuit, we note it to be 0.45 amps, and the bulb's brightness has been reduced. Now it says add a third light to the bulb. So let's do that as well. Let's add it here. So let's split the junction, shift that over just a little bit, if it'll work for me. We're having some troubles here. Just shift that there like that. Add the next bulb, and we'll probably add another wire in here just to make it easier to connect that, and there you go. And so now the current is 0.3 amps, and the bulb brightness is actually even duller compared to what it was before. So the measure of the current of the circuit and note the brightness of the bulb, it's 0.3 amps now, and the bulbs are even less bright. So based on that trend, to answer question number 7, what happens to the current in a series circuit as more bulbs or resistors are added? Well, the answer is the current goes down. What happens to the brightness of the bulbs as more of them were added? Well, the bulb brightness got less and less and less. Okay, now we add some ammeters to the circuit, and we need to do that like you see here. Okay, so let's do that. So we get one before this bulb. Let's split that junction. Let's kind of move that over here like that. And let's add another wire to there. Oop, not there. Put it there where it belongs. Having some troubles here. Let's remove that thing altogether and start over. So there's your bulb and another bulb, or the bulb, and we're going to add an ammeter to that and connect that to the wire. And let's just shift that over here like that. Let's split that junction, add another wire, and put an ammeter in there. So we've got an ammeter between before this bulb, an ammeter between this bulb and that bulb, and we have an ammeter between that bulb and this bulb, and we can probably add an ammeter over here as well. So let's split that junction, add an ammeter over here as well. There we go. So we have an ammeter, ammeters between all the different parts of our circuit here. And then it says measure the current throughout the circuit. What is the current in each of the ammeters? You'll notice 0.3, 0.3, 0.3, and 0.3. So the answer is 0.3. So question 10 asks you, what can you conclude about how current is distributed or spread throughout a series circuit? Well, the current is the same everywhere in a series circuit, as you can see right here. No matter where we measure the current with an ammeter, the current's always the same. Okay, so we're going to stop right there, and we'll finish questions 11, 12, 13 down to 17 in the next video, so that we don't create a video that's too long here. Okay, so we'll see you in the next video. Okay.